Dear children, in previous standard we have studied the first chapter, natural resources, air, water and land in detail. Now this year our third chapter is properties of natural resources. First of all, let us see what is the definition of natural resources. We get many things from nature that fulfill our basic needs, and these things are called natural resources. Now we have studied the examples also: air, water, soil, plants, animals, minerals, rocks, stones. All these are the examples of natural resources, and they fulfill our so many basic needs. And which are our three main basic needs? They are food, clothes and shelter. Roti, kapda or makan. Anna, vastra, nivara. Now we will turn to the first natural resource, and that is air. Let us see some main properties of air. First one is, air is all around us. See, though we cannot see air, but we can feel it. We can feel the presence of air. When we inhale, we feel the presence of air. We take the air inside our body through nose. Now, if I blow on my hand through my lips, I feel the air. In this way, we know that air is all around us. Second is, air is a mixture of gases, and that we have studied in previous standard. Which gases are present there? There are many gases like nitrogen, oxygen, argon, inert gases, then water vapors, dust particles. In this way, other gases are also present in air. The air is mixture of gases. Now, the next is, air has mass and weight. See, for that we will do one experiment. Small experiment that you can do at your home also. What I have done here, I had taken a straw, paper straw, that is light in weight, and to the middle of that paper straw I have tied one thread, and I have inflated two balloons of same size and tied them to the two ends of this straw. What you can see here, the straw is horizontal. It remains horizontal. Now, what happens in this case? Here is also same straw, but there are two balloons, but one is inflated and another one is uninflated. See, you can see it clearly here. Now what happens? I have tied it in the middle, and this is horizontal, this straw is horizontal, but this straw, it bends towards the inflated balloon. It lowers down, and which is upside? Which side is upside? The uninflated balloon. Why does this happen? Because these balloons, they are having air in it, and because of air they have gained some mass, some weight, because air has mass and it has no air, that's why it has no less mass, and so it goes upside and it is lowered. And in this way we have studied that it has mass and weight. Air has mass as well as weight. In our experiment of balloons, we have proved that air has mass and weight. Now we will see air has volume. The definition of volume is that the amount of space occupied by an object is called its volume. That means air occupies space. Now we will prove it with a very simple experiment. For that, what I have done, I have taken one pot of water and one empty bottle. Now this empty bottle, it has air in it, and what I am going to do, I am going to fill water in this empty bottle, and while doing this, the air in that bottle, it has occupied its space, but we have to fill it with water, and that's why what will happen, that air will come outside the bottle in the form of bubbles. See here. See, in this way, we have seen the formation of bubbles here because of air. And in this way, it has proved that air occupies space. Now, molecules of gases in air move constantly. We see that if the window has a hole, and through that window, if the sunlight is coming in a straight line, at that time you can see the different molecules of air, they are dust particles, these are dancing in that sunlight, and also these molecules of gases, they are moving from one place to another place every time. After that, atmospheric pressure of air is same in all directions. That we will prove with one small experiment. See, what is it? It is an injection syringe without a needle. And this injection syringe, if I try to pull the piston of it, it will be pulled very easily. See, I have pulled it, and then if I release the pressure on it, then also it will remain as it is. It will not move forward by its own. I have to push it so that it will move forward. But if it will be released and it will be in the same position, it will not go to its original position without force. We have to apply force, and then it will go to its original position. Now, if I close the lid hole is here, and that I am closing it with the help of thumb. Now this is horizontal position, and what I am trying to do, I am trying to pull the piston, but I can't pull it. See, I have tried to pull it up to some extent, but if I release the pressure, what happens? It will go to its original position. See, I have tried to pull it by applying so much force, but when the force is released, it goes to its original position. Why does this happen? Because there are less air molecules in the syringe now, because the inlet hole is closed, it is covered, and the outside pressure is increased, and that's why it is pushing the piston inside to its original position. Now, if I do it in vertical position, will there be any change? That we will see. See, again I have to pull it very forcefully, and then it will go to its original position now also. That means in vertical position is also, same action is repeated here. Now I will do it in inclined position. See, it is in inclined position, slanting position, and then also I have to apply force. It proves that the atmospheric pressure of air is same in all directions. With the help of this syringe, we have proved it that atmospheric pressure of air is same in all directions, because in vertical, horizontal and inclined position it was same. Now difference in air pressure causes wind. In geography also we have studied formation of winds, and this formation of winds occurs because of difference in air pressure. Whenever there is low pressure at any place, at that time the air, it moves from low pressure to high pressure to low pressure, and there is formation of wind. The cool breeze is there, and that cool breeze is nothing but wind. That means difference in air pressure causes the formation of wind. Then there is presence of water vapors in air. For that, we know that there is formation of dew. In the afternoon, there is high temperature compared to evening or night, and because of that, there is high temperature and the humidity is less in that air. But at night, what happens? There is low temperature, and because of low temperature, what happens? The humidity is more. What is humidity? The capacity of air to hold water vapors, that is called humidity, adrata, and this humidity is more at night, in the evening, because there is low temperature. And because of that, we see in the morning at dawn, if you see the leaves, on those leaves there are small droplets of water, and those droplets of water are nothing but dewdrops. That means dew formation takes place. Now we can do that experiment here also. See, I have taken the ice. See, this is ice, and I have taken ice in this glass. Now you can see the water droplets outside this glass. You can do it at home also. Why there are these water droplets? Because of this ice, the surrounding temperature of that air, it lowers down, it cools down, and because of that, there is condensation of water vapors. Those are present in air, and because of condensation, those water vapors, they get condensed. From vapors, they are converted into water droplets, gas to liquid. What is condensation? There is formation of water droplets from water vapors because of condensation due to low temperature, and these water droplets, they get collected on the surface of that, outside of that glass. In this way, we have proved that there is presence of water vapors in air. This point is also clear to you now. And air particles cause scattering of light. There are air particles, and because of air particles, the light spreads in all directions, and that's why it causes scattering of light. This is very interesting phenomenon in our surrounding. Air controls temperature. See, we know that we get sunlight from our sun. Main source of energy is sun, and from sun we get sunlight, energy, and that energy is taken by our earth, and it is reflected back in the form of heat. It is reflected back in the form of heat, and that heat is absorbed by the atmosphere, by the air in the atmosphere. From this oxygen, carbon dioxide, water vapors, they absorb heat that is radiated, that is reflected back from the earth, and they give that heat to another constituents of air, atmosphere also. And because of that, the temperature is controlled on the earth and we can survive, it becomes suitable for living things, for survival of living things. And due to this important function is done by air. Air controls temperature, otherwise our earth, it would have been very cold. There might have been the very low temperature. Then air is useful medium for sound transmission. We know that air is all around us, and for sound production, sound transmission, medium is required. If there is no medium, there will be no sound production. In vacuum, there is no sound production. But as air is in all, in the surroundings, everywhere around us, because of that, there is transmission of sound. This is the main medium that is useful for transmission of sound. In this way, all these properties, main properties of air, are studied by us. You can revise them and you will be able to do the small experiments given in your textbook at home also. Do those as activities.